size of area is increased. Electrons have some random velocity. Electron has velocity because of the temperature called as thermal velocity, but they do not give rise to any current because of the randomness. Average velocity is zero. There is no electric current even though electrons are moving with very high speed. When we apply some electric field with the help of a battery or a cell, it gives additional drift along with that random motion because of the electric field applied. Electric field is due to the potential difference. Electrons experiences an opposite direction force, and due to which it starts drifting. Why drifting? Because they cannot move continuously. As they start moving, they collide with the other ions and other atoms and other electrons. Therefore, they cannot move. They cannot move continuously. It is just a small drift. And the formula for drift velocity we calculated as average velocity of all the electrons in the presence of electric field, and it came out to be minus E capital E by M times tau. Bharat, what was tau in this formula?
Sir, you're asking for formula for torque.
No, boss, I'm asking what is this tau? In this formula, what is this tau?
Torque.
What does it represent? Yes, what does this tau represent?
Sir, I said it's tau is torque.
टॉर्क कहाँ से आ गया यार? हम मैकेनिक्स थोड़ी पढ़ रहे हैं, हम चार्ज पढ़ रहे हैं अभी, करंट इलेक्ट्रिसिटी.
Sir, relaxation time.
Yes, Rahul, it's relaxation time. And what does that mean? Relaxation time means what?
Sir, reduced time during collision, right?
The time between two successive collisions.
It's between two collisions.
Right? Okay. So tau was the relaxation time, mean relaxation time, which is the time between two successive collision of electron. On what factor it depends? Bharat, you have to revise. You don't revise, that means. On what factor relaxation time depends? Relaxation time depends on which factor? On what factor relaxation time depends?
Sir, temperature.
Temperature.
Temperature. On increasing temperature, what happens to drift velocity? Decreases, because as the temperature increases, the thermal velocity increases, which causes the electron to collide faster. Time between two collisions decreases, drift velocity decreases, current also decreases. Right?
Yes, sir.
Very good. Drift velocity की वजह से electric current होती है, and then we found relation between. So Bharat, you have to write a formula sheet on your own mentioning what is the meaning of each symbol. Tau here is not at all related to the torque, though the symbol is same. And drift velocity per unit electric field, what it is called? Drift velocity per unit electric field is called mobility. Mobility of free electron is defined as the speed or velocity acquired per unit electric field. It is Vd by E, and that will become E into tau by M. So again, the mobility depends only upon the temperature. E is constant, M is constant. E is the charge of electron, M is the mass of electron. Both quantity is constant, so it depends only upon the temperature. On increasing temperature, speed increases. Therefore, time of collision decreases. Speed, which speed increases? Thermal speed increases. thermal speed increases, and that is why, yeah, that is why the drift speed also decreases, mu also decreases. Electron will not be able to move for the conduction. Okay, and then we did the derivation of current. So there are two formulas. First, in the case of metallic wire,
Metallic wire, and there was a relation as well.
beta,
So I'm saying 1 minute electric current in metallic wire, and the other was the relation between current and drift velocity.
yes, yes, and we also would have done for electrolytic solution or for a discharge tube. So first formula that we did was in terms of the total charge flowing through an area. So if it is a wire, metallic wire, there will be only electrons moving. If n number of electrons are moving per second, so n into E is the charge moving per second across that area, where small n is total number of electrons crossing that area in perpendicular direction. Total number of electrons crossing the area. Correct? Small n. And if it is a metallic, if it is electrolytic solution or it is a discharge tube. इलेक्ट्रोलिटिक सॉल्यूशन में दो तरह के आयन होंगे, केटायन और एनायन, and similarly in the gas discharge tube there will be free electrons and positively charged ions, though they both move in opposite direction, but their current will always come in same direction because पॉजिटिव की डायरेक्शन में करंट होती है पॉजिटिव की, एंड इलेक्ट्रॉन नेगेटिव के अपोजिट डायरेक्शन में हम करंट लेते हैं नेगेटिव चार्ज. So the direction of current due to positive and negative are in the same direction. Total current will become I plus I minus. If there are n1 number of cations or n1 number of positive ion moves, I is equal to n1 plus n2 times E. n1 is the number of positive charge crossing per unit time. अभी मल्टीप्लाई ई से करेंगे या 2 ई से करेंगे, वो उस पे भी डिपेंड करता है कि वो आयन कौन सा है. सोडियम और क्लोराइड है तो दोनों पे एक चार्ज के इक्वल है, प्लस if it is suppose magnesium then Mg plus 2, sulfate then minus 2, then it will be multiplied by 2 in the case of electrolytic solution. Right, this n1 and n2 are the number of charge carriers crossing an area in unit time. This is not that electron density. Then we derived the relation of current with drift speed or drift velocity. Current is because of drift velocity only. If there is no current, no drift velocity, no electric field,
Sir,
there
can you
won't
go
be.
back to the previous page?
बेटा ये सब लिखा होगा आपके नोट्स में शायद.
So
Don't
this is
need to
all
copy
from
it
last
again.
class.
हाँ बेटा,
This is all from last class.
last to last class ये होगा शायद, maybe, and last class we would have done, no, I don't know, last class or last class, something like that. Yeah. Bharat,
Yes, sir.
got it?
Yes.
Very nice. Okay, relation between electric current and drift speed or drift velocity. This was on the basis of, we did solve question, I guess I remember, electric current and drift velocity from the second DPP also, maybe. In the when the electron moves, the average speed of electron is drift velocity. So if we know the number of free electrons, if we know the number of number of free electrons per meter cube, or electron density is small n, area of cross section is A, drift speed is Vd. All the electrons which are present up to a distance of Vd, all the electrons present in this volume will be able to cross that area, because distance covered in unit time is equal to velocity, right?
Yes, sir.
Area of cross section was capital A, and so we have to find this, how many electrons are present there. Each electron up to distance of Vd will cross I is equal to capital N into E. Capital N निकालने के लिए हम कर लेंगे charge density, number of electrons per unit volume into volume, and volume is A into V. I is equal to NEAVD. This was the relation between electric current and drift velocity. Here, small n is the number of free electrons present in 1 meter cube per meter cube. Right? Direction of current and direction of velocity will be opposite, but since current is scalar quantity, we will not put here the minus sign. Only this we did last class, and then anything further, current density.
No, sir. This was the last thing.
We only did the years.
Last thing, though, that means we didn't do the DBP as well. Fine. No problem, we'll do it today. Current is a scalar quantity. Current does not have a direction. No, current has a direction. It is considered to be a scalar quantity, and the reason was that current is already fixed and it does not follow the vector law of addition. But if we want a fixed direction only, we choose one single one, a specific area. One specific area, that means in this wire, suppose we consider this as an area, or maybe this slant area, then the amount of current passing through this will change because the amount of area has changed, through which we are considering the total number of charge carriers passing through it. So there is another term, another quantity associated with the current called as current density, which is current passing per unit area perpendicularly, and that quantity is a vector quantity. Current density is a vector, though electric current is a scalar. Current density, capital J, denoted by capital J, it is a vector quantity. It represents the total amount of current passing per unit area. Total amount of current passing per unit area in perpendicular direction. ये परपेंडिकुलर रैंडमली चेंज हो सकता है. क्यों चेंज हो सकता है? क्योंकि हम एरिया का ओरिएंटेशन कहीं भी ले सकते हैं इन परपेंडिकुलर डायरेक्शन, and it is a vector quantity. Current density means current upon area, so it will be I upon A. Current is a scalar, but area is a vector quantity, so this becomes vector. Ampere per meter square, and the direction of electric current density will always be in the direction of current, therefore opposite to the direction of drift velocity in vector form. Correct? So इसे अगर मैं करंट निकालना होगा तो हम क्या करेंगे? करंट के लिए J वेक्टर और एरिया वेक्टर का डॉट प्रोडक्ट करेंगे, बिकॉज करंट इज स्केलर क्वांटिटी. इफ J इज वेरिएबल तो हम J को dA के साथ डॉट प्रोडक्ट लेके इंटीग्रेट करेंगे. दिस इज अनदर रिलेशन for the electric calculation of electric current. If the current density vector is known, then right? Okay. J is equal to I by A. I is ampere per meter square. अगर हम इसको फॉर्मूले से निकालते हैं तो आई था NEAVD divided by A gone. Magnitude wise current density is NEVD. In vector form, if we write the direction wise, then current density is opposite to the drift velocity, so current density J will become minus NE times VD vector. Current density का फॉर्मूला आ गया NEVD and VD के opposite है, that's why we will put a minus sign to denote the direction vector. And since we already have derived the formula for VD as minus this formula that we had already derived, minus E capital E upon M times tau, we can substitute the value of drift velocity in that particular formula for current density. So use that formula for current density, it is minus NE into minus E capital E by M times tau. Minus minus plus NE square tau by M times capital E. This is the vector relation between current density and electric field vector. Small n is the number of free electrons per meter cube, which is going to be constant for a given metal. And in case of metal, it is very, very high already because every atom contributes one free electron. E is charge, tau is the quantity, the time between two collisions, which depends upon temperature. If temperature is constant, then tau will also be constant. And M is the mass of electron. तो मीनिंग दैट अगर टेम्परेचर कांस्टेंट है तो ये सारी चीजें कांस्टेंट है, इसको हम एक अलग कांस्टेंट से रिप्रेजेंट करते हैं कॉल्ड एज कंडक्टिविटी ऑफ दैट मटेरियल व्हिच ओनली डिपेंड्स अपॉन द टेम्परेचर. दिस इज कॉल्ड इलेक्ट्रिकल कंडक्टिविटी ऑफ दैट मटेरियल. इलेक्ट्रिकल कंडक्टिविटी जो हमने 10th में पढ़ा होगा शायद, कंडक्टिविटी का हमने फॉर्मूला डिराइव कर लिया एक तरह से. कंडक्टिविटी इज m NE square by tau by m. This is called vector form of Ohm's law because according to this, J is directly proportional to E. ये इलेक्ट्रिकल कंडक्टिविटी किसी वायर की नहीं है, ये मटेरियल की होती है, which depends only upon temperature. If you change the temperature, only then this quantity is going to change.
Sir,
हाँ बेटा,
this is a slightly different form of Ohm's law.
this is Ohm's law only. This
Sir,
Can you
called,
go back to the previous slides?
yes. Just let me complete it then. E is equal to rho times J, where rho is the inverse of conductivity called as resistivity. It's called resistivity of that material. Yeah, backslide. Okay.
So
Yes,
could you explain the last relation again?
last step.
The last relation in which conductivity is used.
That is the term called conductivity. Greater conductivity, metal will be better conducted. Conductivity and resistivity are inverse of each other. So we can write J as sigma E, or we can write E as 1 by sigma times J. This 1 upon sigma is called resistivity, and resistivity formula becomes M divided by Ne square tau.
And sir, we just have to basically substitute formula of drift speed and we'll obtain the relation.
आपकी voice थोड़ी बहुत समझ नहीं है, फिर से बोलना, come again.
Sir, so basically we just need to substitute the formula for drift speed.
Yes,
And
yes,
here-
yes. We just substituted the formula for drift velocity that we have already derived in the last class. And by using that, we got a relation between current density and electric field. Current density is a vector quantity, electric field is a vector quantity. Hence, it is called as vector form of Ohm's law. Both are the same thing. These are called vector form or microscopic form of Ohm's law. Microscopic properties which does not depend upon size. So like conductivity or resistivity does not depend upon the size of the wire or area of the wire. Therefore, it is a microscopic property. This is microscopic form of Ohm's law, and this comes almost every year to derive in the board exam, either 3 mark or 5 mark, one part of the 5 mark question. But this is not the Ohm's law that we did in class 10, right, Bharat?
Yes, sir.
What we did in class 10, you remember that
V is
formula?
equal to I into R.
V is equal to I into R. There V is scalar quantity, potential, I current is scalar quantity. So that is called a scalar version of Ohm's law, and that we can derive from here only by putting just right. So electric field is V by L, V upon L, or current density is I by A. Now the relation that we have derived, E is equal to rho times J. Substitute the value of E as well as J in this formula. E is V by L rho, J is I by A. V is equal to rho L by A times I, which is the scalar version of Ohm's law, right, Bharat? And this quantity in the bracket is called resistance.
Excuse me, sir.
V is equal to R into I. R is called resistance of the wire. It is a constant, and this constant is called resistance. So we kind of derive the formula for resistance also.
Sir, what will be
It
the
is
value of R?
Avida?
What will be the value of R?
ये तो मेरे माइक में प्रॉब्लम है. Please come again, Meher.
Sir, what will be the value of R since it's constant?
नहीं, ये तो compare करें ना. V is proportional to I. R is this. To
Okay.
compare both the formula. R is rho L by A is written as R. And that R is called resistance of wire. And now this is a property of the wire because it also involves its dimension. It is also depending upon the length. It is also depending upon the area. V is directly proportional to I, and that will be a straight line graph. Here the slope of this line will be giving resistance. हमने resistance का formula derive कर लिया with the help of this microscopic version of Ohm's law. With the help of so here rho is resistivity, the same resistivity. L is the length of the wire and A is the area. So resistance is not the microscopic property. Resistance is a bulk property because it also involves the dimension. Right?
Yes, sir.
Tan theta is resistance, and all those conductors which follow Ohm's law, they are called ohmic conductors. They are called ohmic conductors. Right. So basically, it is not a universal law, not applicable for all the conductors. Very few restricted conductors on a very small temperature range follow that V is proportional to I. But for our assumption, we can assume that resistance remains constant. Resistance is rho L by A. For ohmic resistance, ohmic conductors, the Ohm's law is followed that V by I is constant, and that constant can be written as slope of the straight line, or it is equal to the resistance. What was the actual statement of Ohm's law? If anybody remember from class 10, the Ohm's
Sir,
law.
Sir, can I tell?
sir,
Yes.
At a constant pressure, the potential difference applied at any 2 points is directly proportional to the current passing through.
sir,
Constant
there are also
pressure.
two conditions. The physical state and the temperature should remain constant.
Under the same physical condition, right? Under the same physical condition, and that physical condition is all physical conditions like length, area,
State
temperature,
of conductor.
pressure, density, all must remain same. Under the same physical condition, potential applied is directly proportional to current passing through it. Right?
Sir, without those two conditions, Ohm's law cannot be fulfilled.
Without?
Without the two conditions, the Ohm's law can't be fulfilled.
Yes, because if length is also changing, then R will be changing, then how it will be
Yes, sir.
constant. So in the microscopic version, that does not depend upon the length or area. That current density is proportional to electric field. That's why it's called microscopic. And this is called scalar form of bulk form of Ohm's law. So under the same physical conditions, physical conditions of length, area, temperature, density, etc. Under the same physical condition, Same physical conditions में length, area, temperature, pressure, density, etc. Length, area, temperature, pressure, density. The potential difference across a wire, the potential difference across a conductor is directly proportional to current passing through it. Is directly proportional to current passing through it. ये चैप्टर सर ने शायद ऑलमोस्ट खत्म कर दिया है. मीटर बेस एंड पोटेंशियोमीटर भी हो
Yes, sir.
जाएगा.
Only potentiometer is left.
हाँ, ओनली पोटेंशियोमीटर बचा हुआ है. सो इसलिए फिर भी हम थोड़ा आराम आराम से कर रहे हैं ताकि आप समझ सको. दिस चैप्टर इज वेरी 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 इंपॉर्टेंट फॉर ऑल कॉम्पिटिटिव एग्जाम. और हम थोड़ा और एक्स्ट्रा भी करेंगे.
Sir,
हाँ बेटा.
sir,
Yes.
how important is this from a CBSE point of view?
From every point of view is important. Yes, you do any kind of engineering, you have to do electronics as one course compulsory, and there you need to know all these stuff. Irrespective of any branch of engineering, electronics is a mandatory course, like the computer programming is a mandatory course. So V is directly proportional to I. V by I is equal to, if you do the engineering, yes, obviously. But if it is not following Ohm's law, then for non-ohmic conductors, it is not directly proportional. An example of non-ohmic conductors, an example of ohmic conductors, all the
All
metallic wires like the electric heater and all those bulbs, but only when their temperature is normal. With the uses, what happens that resistance start changing, increasing because of the relaxation time changes, drift velocity changes, so many other factor changes with increase in temperature.
Sir?
And temperature, yes.
There are metalloids ohmic conductors or non-ohmic conductors?
तुम्हारी वॉइस में इको है या मेरे कान में इको है, मुझे समझ नहीं आ रहा.
Sir, are metalloids ohmic conductors or non-ohmic conductors?
Metalloid follows Ohm's law up to a certain extent, yes, but not necessarily. The range is quite small. Like for the metals, the range is quite good. I mean, for the large temperature range, it will be behaving like a ohmic conductors. Ohmic conductors are like metals, mostly the metal conductors. Non-ohmic conductor, it does not follow the Ohm's law. That means current is not directly proportional to the potential applied. So for example, all semiconductor devices like all diodes, diode is a class of material, like example LED bulbs and all those are non-ohmic conductors, come under non-ohmic conductors. Transistors, vacuum tube or discharge tube. So in this case, even it may be exactly opposite. You are increasing potential, the resistance is decreasing. That also might happen. So their structure is also controlled. The current density is also controlled. I versus V for a normal diode graph is like this. It's a curved graph. For some specific diode, it can be made like gallium arsenide. Gallium arsenide has some negative. Gallium arsenide is another example of semiconductor diode, and this is for normal LEDs or diodes. In this case, the resistance is not constant. It will depend upon how much potential you have already applied and it will also depend upon the temperature. Right?
Yes, sir.
So here we define dynamic resistance. In this case, the resistance cannot be treated as a constant thing. The dynamic resistance of non-ohmic conductor is usually denoted by RD. D stands for dynamic. It will be dV by Di for that instantaneous resistance. So it should be either the slope of V versus I graph. In this case, the graph which are plotted here is not V versus I, it is I versus V, because usually when we do the experiment, we change the supply voltage, and the current is monitored or observed. So it is 1 upon Di by dV, and so it can also be written as 1 upon slope of IV graph, current versus potential graph. That slope inverse give the dynamic resistance. It is variable, and we monitor it by changing the potential, by changing the temperature. Dynamic resistance for LEDs. Dynamic resistance is for LEDs and all the other semiconductor devices. Right? Okay, so we did drift velocity, we did mobility, and the relation between current and mobility is E tau by m. मोबिलिटी आपने शायद लिक्विड सोल्यूशन में केमिस्ट्री में पढ़ा होगा, होपफुली नहीं पढ़ा तो पढ़ लोगे. So now we do some questions based on this. फिर हम आगे बढ़ते हैं. Next part we have to do the calculation of resistance. So second DPP and first, I think first we solved a little bit in the class. Second one I have shared. First के तो questions किए थे ना हमने कुछ. First DPP questions did we do in the class?
Sir, no.
लोगों को दिखाने पे याद आएगा शायद. Yes. Yeah, this was the first DPP. I don't remember. Please tell me. Did we do question from here in the
No, sir.
previous? No or yes?
No.
No, sir.
No. Okay. Nice. Okay. So based on the last lecture and today's lecture, now we'll solve some questions before doing further. Yeah. So let's begin with question number 2. One तो अभी छोड़ देते हैं थोड़ी देर के लिए. In a current carrying conductor, are all of the electrons moving in same direction? There is a current. It's not about that random motion. When the current is flowing, then also you have to tell this. All the electrons are moving in same direction, yes or no? These conceptual questions are even far better. Just like in HC Verma, there is an initial section question for short answer. So they check your understanding, conceptual understanding. Yeah. In current carrying conductor, are all the electrons moving in same direction? Rahul?
No, sir.
No, why not? Because they do not have just drift velocity, they also have a thermal velocity, which is randomly. Actual direction which they will be moving will be resultant of the two. Okay, is drift velocity same for all electrons in magnitude and also in the direction? Second question answer, Bharat. Drift velocity is same for all electrons in magnitude and direction, yes or no?
Yes, sir.
Yes?
Yes.
Okay.
Sir, I don't have. I'm clear about it. It is yes.
Explain why. What is the reason why they are same when their velocities are different? Why the drift velocity is same? You have to explain.
Sir, I've realized that I've got my answer wrong.
ऐसा थोड़ी होता है यार, मैंने लॉजिक पूछ लिया तो आप बोलो मेरा आंसर गलत है. That's not the way.
Sir, I'm not sure. I'm not too sure about the logic.
Then how are you sure about the answer then? Yes, anyone else? Drift velocity is same or drift velocity is different for different electrons? And why? Reason also. Renee? It has to be same, quite obviously, because it is the average. जब हम average velocity calculate करते हैं, average speed करते हैं, throughout the motion, that value is remaining same, though the instantaneous velocity will be changing, somewhat similar to that. Yes?
So I didn't understand the reason why drift velocity would be same. I didn't understand the reason why drift velocity would be same.
Because it is average for all, average सबके लिए same ही आएगा. Average लोगे तो thermal velocity will become 0. And for a given drift velocity or an average, direction, magnitude, everything is same. Because on what it was depending. E drift velocity is E, capital E. E तो सबके लिए constant है, mass constant है. Tau times capital E. E is also same. E का कोई लेना देना नहीं इलेक्ट्रॉन के लिए, वो तो बाहर बैटरी ने लगाया. Only difference is tau, and tau is a mean relaxation time, which is same for all. Why the temperature increases if current flows through it for a time duration?
Sir, would it be because there is a decrease in drift velocity?
बेटा मुझे आपकी आवाज नहीं आ रही है मेर.
Sir, would it be because drift velocity decreases with increase in temperature?
What will be
if the drift velocity decreases with the increase in temperature?
Is anyone able to hear him properly? Please repeat the question to me. Well, I think you need to connect your mic again. I'm not getting your voice clearly. Yes. Where you can rejoin maybe. Yeah, I want to answer the question, but I am not clear. Yes, can you come again? What was the question?
Sir, I have written in the chat.
I've written in the chat. Okay, thank you. Yeah. Sir, is it due to decrease in drift speed? Okay, the heat. We are answering to third question.
Yes, sir.
Okay, temperature increases because during the time the electron moves, its kinetic energy is lost during the collision. And where does it go? It goes in the form of thermal energy. That's why temperature is increased. If current is flowing, means electrons started moving, electrons started drifting. Electrons are moving, it requires kinetic energy, suddenly collides with some of the iron and comes to rest. That means all of its kinetic energy is now lost and it converts in the form of heat only. State the meaning of term mobility. We done this. Drift field, it is a scalar quantity. The current flows from positive to negative but taken as quantity. We have already discussed this because it is fixed always, and the second reason is that
Sir,
it does
it
not
doesn't obey the vector laws of addition. It doesn't obey vector laws of addition.
It doesn't follow the law of vector addition. Yeah, that should be the reason you should write in the school exam. Okay. Question number third. Electron in electric circuit pass through resistor. The wire on either side of resistor has the same diameter. How does the drift speed of electron before entering the resistor compare with the speed after leaving the resistor? Okay, so question number third is saying that in an electric circuit, the same area through which the electron enters and through which the electron comes out, what happens to the while entering it is V1, while coming out it is V2. What is the relation between them? I think that's the question. Question number third, first part. How does the speed of electron before entering the resistor compare the speed after leaving the resistor? Explain with the proper answer. Yes.
So let's just speed decrease.
Why?
So because resistor will provide some form of resistance to overcome which work needs to be done. Kinetic energy would be lost.
Because of that only. Because of that only the relaxation time was changing. On an average, it is same for all. Here, what it is saying that I is equal to NEAVD. If you would use that formula, it's the same material, so N is same, area is same, E is same, drift velocity will also be same. Explanation wise, because drift velocity is an average velocity for all the electrons, whether it is going in or it is going out from the wire, it is going to be same. How does the potential energy of electron before entering the resistor compare with the potential energy of electron leaving the resistor? Now, in this case, the potential energy will be decreasing because of its collision with the other atom. Why can we say this? Potential energy keeps on falling. Potential energy of electron before entering the resistor compared to the potential energy of electron leaving the resistor is decreasing, because kinetic energy will be increasing when it is coming out, just coming out. Do you understand this? When it is going in, when just entering into this, it will be colliding. Kinetic energy will be lost, potential energy. When it will be leaving on the other side, it has more kinetic energy, because now there will not be any more collision when it is coming out of the resistor. So it has less potential energy as compared to while entering. So at the time of entry, the potential energy is more. At the time of exit, while it is going leaving the resistor, kinetic energy is more, potential energy is less, so potential energy is decreasing. Correct? Understood the logic?
Yes, sir.
Yes, sir. Got it.
Question number 4, that's the numerical one. In first part only we need to do, or first or second, no. In a hydrogen discharge tube, the number of hydrogen ions, proton drifting across a cross-section area per second is 1 into 10 to the power 18, while the number of electrons drifting in opposite direction will be 2.7 10 to the power 18. Find the current. So this is a discharge tube where current is due to both as in positive ion plus negative ion, or positive charge plus negative charge. The current due to both will be added. I will be equal to N1 plus N2 times E. This is a hydrogen ion, so charge will be similar to charge will be only 1.6 10 to the power minus 19. You have this, so you can check from your DPP, from your WhatsApp group. I want to do it a little fast. It's very simple. I is equal to N1 plus N2 times E. That was the formula for total current when there is a discharge tube or when there is an electrolytic solution. Yeah, what is the answer? What is the answer? बेटा आंसर सॉल्व करना है, सिंपल है. N1 plus N2
Sir.
1.6.
Sir, I'm getting 2.86 into 10 to the minus 14.
ये यार अपना माइक चेंज कर लो. Answer is 0.592. I think so. 0.592.
Yes, sir.
Is it coming?
Yes, sir.
Sir, I'm not getting the right answer.
2.7 plus 1, that's how much? 3.7
Yes,
into
sir.
10 to the power 18 into 1.6 into 10 to the power minus 19. What is the problem? 5.92 into 10 to the power minus 10. Just you need to calculate this. 0.592 ampere. Right?
So I have a question.
Yes, sir.
Yes, yes, Arnav.
So
Please.
if in case of protons and electrons, there were just protons and one batch was moving in one direction and the other was moving in the other. So तब भी हम add करते हैं subtract करते हैं.
तभी add करेंगे because they are moving under some potential difference only, and that potential difference will always make the proton to move in opposite direction, electron to move in opposite direction, and therefore it will be
Yes, I
adding.
was talking about a situation in which, let's say, protons are moving from left to right, and there's another batch of protons which is moving from right to left.
Then we have to subtract, but practically it is not possible.
It's not possible, but we have to subtract.
Practically it is not possible. We have to use two different.
Yes.
Right. Second answer, voltage applied is 230. Find the resistance. We have current. R is equal to V by I. Very simple. I'm not that cutting and copying the question there because you have this DPP. So, right. Fine. Next. Next, relatively, we didn't do any question from this DPP.
So no,
No, sir.
none.
Okay, so second one is very easy. I is equal to N into E. If you want to do, you can do it later on in the homework. Question number 6, 7, and 8. 6 says the graph of current versus time is given as this. Charge that flows through the wire in 7.5 seconds is Q1, and that flows through the wire in 15 seconds is Q2. Then the ratio. Charge will be integration of I dt, and integration is also calculated as area. So if we calculate area under current versus time graph, that first area will be Q1, second area will be Q2, which even you don't need to calculate, you can directly say that is the same length, so it is 1:2. Such two triangles will be there in that rectangle, but if you want to calculate, you can calculate with the right.
Yes, sir.
Yes, sir.
Question number 7, you have to put the I as a function of time and then integrate. Yes.
$612.
612. Right. 612 is the answer. Simple integration, and I hope everyone got the answer. Question number 8. Charge is given as a function of time. Current through the conductor. Current through the conductor is I is equal to Q by dQ by dt.
$12.
Yes. 12. 12. dQ by dt. किसी को नहीं हो रहा हो तो पूछ लेना. This is very simple, so I'm not using it. Question number 9. When भी थोड़ा important discussion है because हमने कभी पढ़ा था मेटल के अंदर इलेक्ट्रिक फील्ड नहीं हो सकती. And in this case, the electric field is the one which is causing the flow, which is causing the electron to move, right?
So is the B option?
Avida?
Is the answer B? Outside the wire but perpendicular to its length?
Answer is inside the wire along its length.
Okay, sir.
Inside wire. अब लेकिन ये electric field आ कैसे गई? That is, I think, next question somewhere. And the next one, we are able to get fairly large current in the conductor because this is a question that I asked in the first class. जब हम charge की बात करते हैं, we say that 1 coulomb charge is not even possible. But here we can easily see that 100 coulomb and 100 coulomb per second, 50 coulomb per second can pass very, very easily. What is the reason? Why there is so much of electric current possible but not the charge? Yes. Understood the question?
Yes, sir.
कंडक्टर में लार्ज करंट हो सकती है, चार्ज नहीं हो सकते थे, क्यों? Why?
So the number of electrons is very high. So B option.
The reason was that number of density electron is very high. Correct. Absolutely correct. The number of electron density is very high, and that is why it can have any number. Okay. ये question number 11 अभी छोड़ देते हैं. Next is, yeah. When a current flows through a conductor, temperature increases, that we have just discussed. Question number 13 and 14. 13 and 14.
So A option. Question
number 13, what should be the answer?
A option.
A option. Why?
So I is equal to NEAVD. So if area is more, current will be double.
A.
I is equal to?
NEAVD.
Okay.
So if area gets doubled, so I will also be doubled.
सर C होगा.
C होगा. It does not depend upon area.
यस सर, मतलब जितना करंट अंदर आएगा उतना ही बाहर जाएगा.
उतना ही बाहर जाएगा. Charge has to remain conserved. If you're using that formula, Arnav, then VD will change. Drift velocity is not same at point A and B. Those are the questions in the next DPP.
Sir, I didn't understand this question.
बेटा वायर का एरिया बढ़ता जा रहा है. If we pass some current through it, then question is what happens to the current? Is it increasing or it will remain same? So we discussed that it is same because it is the amount of charge which is flowing. The area is only used for reference. It does not have anything to do with.
So current will remain the same.
Current will remain same, but as Arnav used the formula that NEAVD. If you are using that formula, then also it will be true because VD, drift velocity, is changing. It is not same.
Okay, sir.
Right? Okay. Question number 14, similar to the first one that we did. Question number 14, what will be the answer?
B.
What is the answer is A, 1 milliampere,
Or is
right?
A?
N1 and N2 is given, N1 plus N2 times E, and the direction will be towards in the direction of proton. Proton is positive charge is moving towards right, so current will be towards right. It is a similar question as we did. Okay, fine. Sure. So now I'm sending the second one. Second one I have sent. Open the second one, and we will solve this second DPP, which is based on the lecture that we had yesterday and today. You have shared in the group, so I'm not cutting and pasting there. That wastes a lot of time. Yeah. First question. Explain a good electrical conductor is also a good conductor of heat. Why? Why a good conductor of heat is also a good conductor of electricity?
So since they both have free electrons, so in case of electricity, the electrons can go to conduct electricity, and in case of heat, they can vibrate to conduct some energy.
Because it is due to the movement of electron. Electrons can move because of drift speed and because of thermal speed. The thermal speed responsible for it is the electron only that propagates the heat, just like the drift velocity propagates the current. What would happen to drift velocity of the electron if wire has no resistance? There's no resistance. What will happen to
Then will drift velocity be 0?
it will be zero.
So they become infinite.
What is your explanation? Why it will become zero? Yes. Why will it become zero?
I'm not exactly sure.
Yes. Anyone else?
So will it become infinite?
Avda?
Will it become infinite?
It will actually increase. Why it will increase? Because drift velocity के फॉर्मूले में था E into tau by m, right? Right?
Yes, sir.
And the tau is relaxation time, and relaxation time is coming because of collision. It is coming because of collision. So that collision is causing the electron to stop, and because of which the relaxation time is small. When there is no resistance, there will be no collisions or less collision or no collision. In that case, what will happen is that it is going to increase all the way. It will not stop because there is no collision. The collision that stops it. Got it?
Yes, sir.
Okay. Next is if a charge flow very slowly through the metal, why does it not require several hours for a light to come on when a switch is on? This is a good question, as also as in board. So I'll give you a better idea with this question number 5 first. What is the order of drift speed? Drift speed is of the order of few millimeters. So it is 10 to the power minus 2. Now what it is asking is that if the drift speed is so small, why does it not require several hours for the light to come when switch is on? Why it comes instantaneously? You think? I'm just coming back. Yeah, extremely sorry, your parents was on the call. हाँ, किसी को आंसर मिला इसका? Why does not take several hours?
Because the electrons are already present.
Current
so-
is due to flow of charges. So if just a single charge passes, maybe due to that.
Let's say it is a 10-meter wire और हमने कोई बैटरी लगाई. Electron is drifted, but now drift speed is few millimeters per second. So what the question is asking that why it doesn't take that long for electron to come or electric current to appear. What is the reason? Because
the
it is
electrons
not
are already there in the wires. It just keeps approaching.
okay.
Like it's on the
All
door
the electrons keep
and
on
giving potential difference just puts it in immediately.
Okay, right, you're in the right direction. So potential difference applies the electric field. Electric field is the reason, not the motion of electron. Electric field is always established with the speed of light. It's through the photon. So however long it is, electric field will be, as you switch or close the switch, it will be instantly developed throughout the circuit, and which causes the every electron to experience a force. So whether it is the first electron or last electron, each start drifting. So every area there's an electron. The electron which is exactly on the boundary will come out and then goes from other side. So the whole wire, every cross section, the flow of electron occurs, which causes the electron to the electric current to appear instantaneously. How so long the wire is? Because it is the speed of light which is responsible to develop the electric field. Right? Correct? Okay. So I think ये दो तीन question हम कर लेते हैं. Electric field is required inside a connector so that current flows through the connector. In electrostatics, we concluded that electric field inside a connector is zero. We did electrostatics that electric field inside current is zero, and here we are saying that electric field is the only reason because of which it is able to move. How do we explain this? Why there is electric field now possible? Understood the question? Understood the question? I'm asking, understood the question?
Yes, sir.
Yeah, what should be the reason? Like, how do we explain it? What is the reason why now there's electric field inside, but initially it was not? Okay, I'll explain because there's not much time left. The reason is that in electrostatics, the electric field was due to the charge on the conductor. Then we say that electrostatic equilibrium, any charge given to the conductor, it comes and reside on the surface. It cannot produce electric field inside. That electric field is zero because of the charges. Here, there is no charge. We discussed already. In the case of current carrying wire, there is no charge, no electric field. Now, the electric field that is established has nothing to do with the charge. It is because of the battery terminals are connected, or battery potential. One is at higher potential, so it is everywhere, not inside, not outside. Everywhere there's an electric field, and this electric field can be present inside because that source is different. Its source is not charged. It is because of the battery potential difference. Correct? Okay, so these questions 2, 3, these are good questions. So we'll solve in the next class. Thursday we'll first solve this TPP, and then we'll do further because theoretical part you have already done, already covered. So that's why I'll be taking more time towards the numerical solving in the class. Okay, thank you.